In question number 25, it is saying which one of the following complexes will not show GI, that is geometrical isomerism. So complex number A is of the type MA4B2. E or B is of the type MAA2B2 because ethylene diamine is a bidentate ligand. C is MA5B and D is of the type MA2B2. So let's draw the arrangements and conclude what will be the correct answer. So for MA4B2 we can have two arrangements of the following type. And another arrangement obviously will be the cis one, where the angle between the two B atoms is 90. So this is trans and that is cis. So obviously it is showing geometrical isomerism. For complex B, we have again two such arrangements. That is, the bidentate ligand occupies the square plane of the octahedral complex, or it can be arranged where in another type wherein the angle between the B atoms is not 180 but 90. So in that case, okay. Now it is important to mention over here that transform of this complex never shows optical isomerism, but the cis form can shows. Okay, so expect questions of that type also in near future. Now in the other one, either way, there will be only one type of arrangement. And so it is not showing any GI. And for the last complex, that is complex number D, we will say there can be two possible arrangements. The first one over here I am drawing right now is trans, and the second one will be obviously the cis. So obviously our answer over here is going to be C. Question number 26 says, which one of the following complexes exhibit optical isomerism? So for A, which is saying cis, alright, that means my arrangement is of the type as it is a Ma2B2 complex square planar. So cis means two similar donor atoms will be placed on the same side of the square plane, and the other two also occupies the same side of the square plane, and this will have a sigma plane of symmetry passing through it. I mean through the square plane, cutting the donor atoms, spherical donor atoms into two halves, or one can consider one plane going like that. Okay, so no optical activity. Next one, complex number B, which is of the type again MA2B2. They are saying it is trans, so let's draw a. So no doubt Here now the two similar donor atoms are at an angle of 180, but if we consider the square plane, now this square plane, one can think a sigma plane through the square plane, and that will be cutting the donor atoms into two equal halves, because each donor atom is like behaving like a spherical atom. So this also will not be showing any optical activity. This is a octahedral complex wherein En is a bidentate ligand, so it is Ma2B2 type, okay, and it is trans as they are saying. So trans means the bidentate ligand will occupy the square plane, and then one can draw the chlorine or B atoms at a angle of 180 to each other. That is, this is the trans arrangement. Now over here we can think of a square plane connecting the donor atoms A, and this can be thought of to be the sigma plane that will be dividing the molecule into two equal halves, because on the top you have B and below also you have B. For a CO-EDTA complex, okay, this complex, if I draw the complex, it will be easier for you to understand, because you will find that there are no such sigma planes of symmetry inside it. So this is CO, and let's place the N atoms on one side of the square plane, and that is connecting them. Then we have the O atoms coming from the acetate, just like that. So basically it is something like that. Then we have this, okay, and then we have something like that. We have something like that. There is another connector here, which is, so that way we can think of this is our CO-EDTA complex. Obviously here oxidation state on cobalt is 3. Alright, now you can see that there is no such plane of symmetry that can be possible for this. Rather, this complex will show optical isomerism, and hence CO-EDTA will be our answer for this question. Again, we have been given, consider the following complexes and which of the complex ions given show optical activity. Again, as we know from the previous sum that we have done in this lecture itself, B cannot show optical activity, as we have already drawn it over here. As you can see, this is the one I am talking about. So this is your complex B, which is trans COEN2Cl2. Here AA is your En, and B over here is your Cl. Now cis COEN2Cl2, this also we have drawn somewhere here. I'm just showing you. This is the one. Okay. So you can consider now over here that M is CO and AA are En, and this B is your Cl2. Now this complex also does not have any plane of symmetry, so there will be a mirror image for this particular complex, and I will draw that for you. So you have M Okay, the mirror image for this will be similarly for the complex number 1, it is of the type MAA3 n plus minus. So this also will not have any sigma plane of symmetry, and hence it will be showing only and only optical isomerism but no geometrical isomerism. So over here we have, so all you got to do is connect them like that. So this is your En, the AA over here is your En, and hence the mirror image for this one will be alright. So that is how you have to think. And just draw a line to indicate the mirror plane. Okay, so that is how we have to find the answers.